you named it the same as some name of some executable program in user bin, you would actually, it would be really hard to run this, because every time you went to run it, it would run the one up in user bin. Okay? And that's where this command which comes in. Right? There's a command which that shows you which PWD you're running. Okay? Maybe there's a bunch of different versions of it out there, but it'll show you which one you're running, and basically the one that you're running is the one that's first in your path. So here it's /bin/pwd. Even if there was one in user bin, that's not the one that's going to be run, because there's one in /bin. Okay? So the which command just sort of looks for that, tells you which one it's finding, which one is the first one that it found in the order that's in your path variable. Now let me show you actually how to set an environment variable explicitly. Okay, and we've done this before with the display environment variable or with the path environment variable. Let me explain it to you again, and maybe it'll sink in more since we've been talking more about environment variables explicitly here. Okay, so one of the ways to do it is just to give the environment variable, give an equal sign, and set it equal to what you want. So like I was saying, sometimes you want to set term equal to VT100 when you're using a telnet connection, okay, if things are going wrong. All right, so term equals VT100 will do that, and then what you do is you say export term. Now this makes like the term variable that you just set sort of take effect. Okay? And now if you do an env again, you'll see down here the term variable is now set to VT100. Okay? Now let me show you the other syntax to set these. You can do it all in one line. You could say export term equals, and let me change it back to what it was, xterm. Okay, so here you just say export, you do it all in one line. Export followed by the environment variable name followed by the value that you want to give it, and you do that, and again I can type env, and you'll see again that the term variable has been changed. This time it's been changed back to xterm. Okay? Environment variables can be set for everyone in the system up in a file called the etc profile file. Okay, so if we look in this file, here you'll see an example, the path variable is being set here. Okay, now there's a few if statements here, but basically let me just explain what this line does. Okay, what this is doing is it says take the path variable and set it equal to this thing over here on the right, and what's over here on the right is the /sbin directory, and the colon says append that on to what the path is equal to already. Okay, so this says add sbin to my path. That's basically what this line of code says. This line of code says add user sbin to my path. This line of code says add user local sbin to my path, and so on. Okay, so this is what's happening here. This is how you set up the path environment variable for everyone on the system. You do that in the etc profile file. Okay, now if you want to set something just for yourself, like you want to add something onto your particular path but nobody else's path, you would do that in your own user configuration files. So let me quit out of the etc profile file here, and let's look at the bash profile. Okay, this is where you would change your own personal path. So if we look at this file, you'll see in here I set my own path here. I said, okay, keep the path that's already there, but append onto that $home/bin. $home is another environment variable that's equal to home Perry. Okay, so this environment variable says add home Perry bin onto my path, and add it onto the end here. Okay, you notice that, and then I'm adding it onto the end. So I want to have all these path places take effect before home Perry bin. Now let's poke around and look at some system configuration files and the startup scripts and that kind of stuff. And remember, I told you that stuff was in the etc directory and its subdirectories. So let me switch over to be the root user here so we can poke around and see everything that we want. And let's go to the heart of it all. Let's go to the /etc directory, and we'll do an ls here. And a bunch of stuff just scrolled by the screen. Let's go back and look at some of that. There's all sorts of files in the etc directory that we've already dealt with. Right, like resolve.conf, which was the file that where we listed all of our name servers for our internet access, that kind of stuff. There's the etc password file, the etc shadow file. There's the etc group file. We saw all those things. There's the host allow and host deny file. That stuff, okay, we've seen that. There's the X11 directory, which sets up, the configuration files for X Windows. The PPP directory, which is where you would configure the point-to-point protocol. Okay, so lots and lots of stuff is in here. What I want to do now is go to the rc.d directory, which on Red Hat is where the system startup scripts reside, and we'll talk a little bit about Runlevels and how all the startup works and so on. So let's go down into the rc.d directory and look around a little bit. there's a few subdirectories in here, RC0 through RC6, that we'll talk about in a few minutes. And then there's RC local, a script, and RC sysinit, which is also another script. RC sysinit is the system startup script for Red Hat. For other systems, it might not be in the etc rc.d directory, it might be in the etc init.d directory, it might not actually be called rc.sysinit, it might be called rc something else, or it might be called sysinit.rc or something like that. Okay, poke around in your system, look in the etc rc.d directory or init.d directory first and look for it. Now the rc.sysinit script that starts up the system is a beast. I mean, this thing is like 50 pages long, okay? And don't mess with this script. Leave it alone, because there's, if you try and pull something out of the script or add something in the middle or something else probably depends on that, and you might mess everything up and your system won't boot. Okay? The way to do it is if you want to add something to your scripts, add it to the rc.local script. Okay? And if we look at that script, okay, you'll see that this is executed after all the other init scripts. Okay, you can put all your initialization stuff in here, and nothing that gets done prior to this is going to get messed up by putting it in RC local. Okay, RC sysinit does everything from mounting disks to file system checks to loading fonts so you can see characters on your screen and everything like that. Okay, and you don't want to mess this script up. All right, so let's take a little aside and talk a little bit about Runlevels, and then we'll come back here and look at these various directories. Now let's talk about Runlevels a little bit. There's different run levels in the computer, 0 through 6. And each run level represents sort of a different state of the system. Run level 0 is the off state. There's nothing running there, so it shouldn't even be called a run level. Then there's run level 1, sometimes also referred to as run level S. That's not a 5, okay? So run level 1 is single user mode. This is what you would be in if you were like recompiling the kernel or trying to recover some files off of disks or something. Something where you don't want anyone else logged on the system, and you might have to do some reboots and things like that. You don't want anyone else on the system, so you would be in run level 1. Run level 2 would be a multi-user mode. It would have all the functionality out there except for networking. Run level 3 would have multi-user mode with networking. It's like sort of one step up. Run level 4 varies from vendor to vendor, what exactly is running at run level 4. You can check out your system and see what's there. Run level 5 has all the functionality with the X Windows environment. And then run level 6 causes an automatic shutdown and a reboot. Okay? Now, what happens is when that startup script takes over, basically the first thing it does is it checks and sees which run level it's going to go to. And it looks in some file. I'll show you how it looks for that. And then it determines which run level it goes to, and then there's a startup script for each of these run levels. And the main startup script calls the independent startup script, so there's like RC1, RC2, RC3, RC4, and so on, and each of those scripts carries out the actions for that run level. Okay? And you can get whatever services, extra services you want running at each run level by altering those scripts, and I'll show you how to do that in a couple seconds too. So each of these directories, RC0, RC1 up to RC6, corresponds to a particular run level. And each of these directories has information in it that the startup script is going to use to decide what services to start and stop to enter that run level. What services will be running when the run level is entered. Okay? Let's look at one of these directories. Let's look at RC1, okay? And by contrast, we'll also look at RC3 in a second. But let's talk about this for a second. There's two kinds of files in all of these RC directories, okay? There's files that start with K, and there's files that start with S, okay? And you can see the S ones over here, and all the K ones are up front, okay? The files that start with K correspond to services that must be killed to enter this run level. So if this service, if the NFS service is running, then it should be killed to enter run level 1. That's what this says. Okay? If the LPD, the line printer daemon, is running, it should be killed to enter run level 1. Okay? Now the S corresponds to services that should be started if they're not running already. So the service single and the service key table should be started to enter run level 1. Now let's contrast this with run level 3. Okay? And you'll see here that much fewer services are killed and many more services are started.
Okay, and they just relate, you know, like we said, RC1 relates to run level 1, which is single user mode, and RC3.g relates to multi-user mode with networking. So obviously, more services will have to